going to look at packaging software in Linux using RPM. This training is primarily aimed at system administrators. It is good that if you have worked on Linux, but if not, it will give you an idea about how the packaging is done. Most of the time, the Linux administrators work on packages. So they install packages, they upgrade packages, they remove packages, or they remove softwares from a Linux system. But they never get involved in creating a new package or adding a patch to a package. So this training is also going to be have a demonstration, which will be done by Abhinaya later in the session. This will give the system administrators an opportunity to see how the software is packaged that the administrators typically use to install on the servers. So this training will be conducted in two parts. The first session will be taken by me. My name is Naveed, and I work as a consultant in Wipro. My primary responsibility is to manage a team. We work for an account called Nokia from Kochi, and as a part of the regular day-to-day responsibility, day-to-day job, one of our responsibilities is to provide packages to customers, to the customer. So in the first part of the training, I'll give you an overview about what software is, what package is, and what source code is, etc. And in the second half, Abhinaya will give a demonstration of how a package can be created, how a Linux package can be created using RPM. So if you have any questions in between, please feel free to ask on the chat window. Make sure that you're sending it to everyone. So if at all I'm not seeing the chat window, Abhinaya can respond, or someone else who knows the topic can respond. Obviously, one of the first questions that comes to mind, especially if you're a newbie in this field, is what exactly is packaging and what exactly is package? But I believe even before we talk about packaging, we need to understand some basic fundamentals of what a software is and how it is made available in an operating system. So most of the talk here will revolve around Linux. So from a Linux point of view, as we all know, the most common and the most popular operating system in the Linux world, especially in an enterprise environment, is Red Hat Enterprise Linux. So in Red Hat Enterprise Linux machine, you will have different softwares installed. And different softwares, and these different softwares that are installed on your Linux machines are made available for installation using a package. So we all know that Linux, one of the great advantages of using Linux is that it is open source. So by open source, you know that we mean that the source code of the software is available, is publicly available. So if the source code is publicly available, and that source code has to be converted to a software before it could be before it's packaged and installed on the server. Now, when I say this, it will be a bit confusing for you. But for those who have worked on Linux, I plan to start showing you some codes so that you can understand what this really means. So, I've got a I got a Linux machine here, which I'm logged into, and I hope the screen is still visible. And this is the Linux machine that you and me regularly works on. Now, if I want to install a software, I typically use something like yum. I think we need to mute someone. So as a regular system administrator, the way you work with packages that you use commands like yum or RPM. So installing a package would be something like, or installing a software would be something like yum install the software name, and it's already installed. That's also installed. That would also be installed. No. Okay. So this is the procedure that we go through regularly when we have to install a software. So you can see that I have typed the command called yum install wget, and the package and the software actually got upgraded to something like this. So now what here is actually package, and what is software, or what is the code here in this case. That is the primary thing that we have to look at before we can actually start building packages. Now, in the Red Hat world, we use the package. We use the word package very very much similar to the software. So when we actually install wget, I would call wget as a software that is made available to us. Now, once the software is installed, what has happened is that certain files have got placed in certain directory. Now, this wget is as a package was available in some kind of repository here, which is what has got installed on this particular server, or upgraded, got upgraded on this particular server. So now, so a package is a way of distributing software, just like we saw wget. Wget as a software, when I install using that command, it actually placed a lot of files in different directories. It placed all these files in different directory structures. So all these files together is my software. Okay, so you may have a file in etc, which normally is a configuration file. You might have a file in user bin, which is a binary, and you may have many other files. In case of wget, we have only these two files other than the manual pages, but some other software may have many other files, which together make sure that wget as a software functions or performs all the functions that wget is supposed to function. So when I installed, all these files got placed into a particular directory structure, and that is exactly what a package does. A package contains all the files, and also it contains the scripts to make sure that the files are placed in the right directory structure. So if you look at, we can actually look at the we can actually look at the scripts RPM minus Q minus scripts that we get, I think. Okay, so the package contains these files, plus it contains the scripts, so that the relevant scripts, so that the packages, the files are placed in the necessary directory structure. So this is, and what are the packages? Now, when we executed the install command, it got installed from a repository called RHEL6 updates, and it actually updated it in the backend. We'll come back to how yum works and all later on, but to understand this, just demonstrated how the software gets installed and where it gets installed. So packaging is all about that. It makes sure that all the binaries or all the configuration files or all the manual pages that a software would need, or a software that a software would need for the proper functioning, is made available in a single file and typically stored in a repository kind of place. So we are all, most of us might be familiar with the Red Hat way of packaging, and as we know, Red Hat provides the package in a file format called RPM. There are other Linux distributions. Which has different ways of packaging. The Debian and the derivatives of Ubuntu packages in .deb format, whereas Solaris uses some kind of it uses a .pkg format. The way the packaging is done, the way the tools are used to actually package it are different, but the concept is same, that whichever the package is, whether it be an AX package or a Solaris package or even a Windows package, it contains all the files that the software needs to run on a particular operating system, as well as it contains all the scripts that are needed to make sure that the software is installed, or software is upgraded, or software is removed properly. Before we get into the next slide, I want to give you another demonstration about a software called Nano. Okay. Nano is a editor. It's a small editor, and it's a small text editor. Now, earlier I said that most of the Linux softwares that we have are open source. Now, here we are looking at the open source repository for Nano, and let's go to the main page, and you can see here different files. Now, are these the files that actually get copied to the server, or are these the files that are packaged and copied over when we do the yum install command? Actually, no. This is the source code, and source code generally means the code or the piece of software that is in a high-level language. Before this software can be used, or before this source code can be used, this has to be converted to this has to be compiled to a high-level language that the particular machine can understand. So this is the code for this particular software. Now, I need to download this. I need to install this. I need to compile this, and then I need to install before I can start using the software. So what I have done is I have actually downloaded the source code. So the entire source code, all these files together, I would call as the source code for this particular software. What I have done is I have downloaded this this file. This says nano 2.9.7.tar.gz. This is a compressed archive of the source code for 2.9.7. So I have downloaded it here, 2.9. And you can see this is the compressed data. This is the compressed source code. So let's create a directory called nano and extract it here. Extract it here. Maybe something wrong. Well, even if we extract, what we are going to see here, what we are going to see in my Linux machine is the archive, is the are these files, okay? Are these files? Now I need to compile this before I have to before I can start using. I have to compile this and I have to install it before I can start using the software. Now, what do we do on a regular basis, or what does the system administrator do on a regular basis? He doesn't actually download the source code from here. He doesn't compile it. He doesn't then install it. All he does is he just installs using the yum command. So when he installs using the yum command, say I am going to install, say, a software called Nano, which we just saw. It says it's already installed. What it does is it searches for this particular software in the repository and then installs it. Now, in this case, it's already installed. But in the repository, what you normally see are files like this. Now, this is the repository that I have configured on my Linux machine using the yum repo configuration file. And this software is actually made available using this RPM. Now you see here the .rpm file, and this is actually your package. Now, is this package or is this file really contains the source code that you saw here in this repository? No. This source code is converted into is compiled into a high-level language, compiled into a binary before it's made available as RPM. So your RPM typically only contains the binary. That is why if one were to install a software called Nano, you would see these kind of files, and these are all, especially the user bin one, is actually a binary, as you can see here. So that is what normally a system administrator wouldn't see what happens in the background. What he normally sees is he only sees this repository. He only runs the yum command or the RPM command. The most that he would get to play around is with the RPM files. Now, so I have some RPM files for you here. For example, this RPM file, nano-2.0.9, this is the same that I downloaded from my repository here. So this RPM file actually is again a compressed archive of all the binaries and all the files that are necessary for the functioning of that software. So just to put this into perspective, I want to make it very clear that we have different files here. Okay, we have different files here. One is that you have the source code. Okay, you have the source code, and let me change the color. You have the source code. Source code contains the software code of the software in a high-level language. Okay, in a high-level language, and then this is actually compiled. So the source code is compiled using tools like GCC or Fortran or COBOL or any other compiler. Even it can be a byte code compiler like Python or Perl if the source code is actually in Python or Perl. So it's compiled into compiled for the particular operating system or the architecture, and then it is packaged in a form is what RPM is, and that is what you get as .rpm file. And then that .rpm file is installed on the server using commands like rpm or yum or apt in case of Ubuntu. And when it gets installed, it actually places the files inside the RPM, inside the .rpm, into the directory structure, into a directory structure that is relevant for that software to function properly. So this RPM is again a compressed, is kind of an archive. Is kind of a compressed archive. Now, if I were to just move this to the RPM to nano, the directory called nano, and then if I were to just say RPM to CPIO, nano, CPIO. So what I have done here is I have extracted the contents of this RPM and into the current directory. So in this case, I have this directory structure created. So ls user bin nano is a file which I extracted from my .rpm file. Okay, so this you can see that this is also actually a binary. So it is a binary. So the RPM package. What I want to emphasize is that the RPM package contains actually the binaries or the software in a completely cooked form that it is ready to be served. It is ready to be used on a particular architecture or a particular operating system. So moving on from where we stopped, we briefly touched based on the installation directories. By default, Linux has a standard directory structure. In the case, no one is stopping you from putting configuration files in user bin, but that's not the best practice. And when it comes to packaging, it is also not a best practice as a package developer or a package maintainer to have your scripts write, to have your pre-install or post-install scripts write documentation files to user bin. The user bin is for binaries, for executables, like we saw the user bin nano, and then user lib contains library files. which supplement the binaries with commonly used or commonly shared functions. Same for user libs before, where the 64-bit libraries are available. Or copied, some package would need certain libraries, or some package would contain certain libraries which are installed into that particular directory. We already touched base on the RPM, the yum command. Just install, we just saw the install option. But for those who don't know what RPM and yum are, they are also, on top of being a software itself, they are also commands. So why I say a yum is also a software is because I have it installed here, or RPM-QA grep yum. So I have it installed here. This is a software that has been installed on my server. So if I use yum info yum, it says that name is yum. So yum is also a command which I executed. At the same time, it's also a software that has been made available through a package, definitely. And RPM is also again a tool which is used to install, remove, and upgrade softwares. Yes, RPM and yum come by default on all RHEL environments. They are kind of the very basic for package management. So even before some of the softwares are installed, RPM has to be installed, or yum has to be installed. And yum is actually a wrapper around RPM. So yum is built using Python, and it makes sure it makes the life of the system administrator easier by making sure that it looks up certain repository, by making sure that the dependencies are resolved, and you can see a history of the software that I have installed on this server. So again, this in the background uses the RPM logs or the yum. It uses the RPM commands in the background to gather these details. So yum is mostly specific to RHEL again. So I hope, Divyanshu, I answered your question. And moving on, some of the common options that we use with the RPM command. Now, the RPM here, it actually deals directly with the package, not even the package name. So like how I have using the yum info command, I can actually say, let me clear the screen, yum info, say nano. So here I am only giving the software name here. But if I have to install using the RPM command, I will have to give the package file directly to the RPM command. So I have nano here, but because nano is already installed, let me remove it. Yum remove nano -y. No. Y. So I removed nano, and now I can install the software using the RPM command, RPM -I for install, and nano. I give the RPM name. If I just give nano, I think it doesn't install because it doesn't recognize this as a package file name. So I have to give RPM package name or the package file name. And once now it is installed, you can, okay, now it's installed and I can verify using the rpm-q command, rpm-q package name, and that's what actually is shown in the slide. So and these are some of the commonly used commands. Now I'll just remove this again using the rpm command, rpm-e nano, and the software is now removed. I can Q is for query, just querying it. It says package is not installed. Now I'm just trying to install again using the yum command, yum install nano. Now another advantage of using yum is that I think I told earlier that yum is able to look up a repository or a set of repositories that is configured on the system. Now I have a set of repositories which is configured in this system. Sorry, I'll clear my screen and then run the command again, but not the cat. So I have a lot of repositories configured, or I have a lot of repository configuration files inside this directory, and this directory contains those repository files. So this repository file may have different repositories. So this tells me that there is a repository called NSN, where it gets the packages from this directory, and that is the directory that I showed you here. So the yum is able to get, say, I want to install something like a subversion. Subversion would be installed. I want to install some small package, say Ebert. So I want to install a package called yum Ebert, or say yum install HTTPD. Okay. So say I want to install HTTPD. So suppose I only had the package available. I only had this. So what I do is, let's just duplicate it. So I have the package file. Now if I try to install using rpm-, I give IV H, I is for install, V is for verbose, H is for header. So it says that failed dependencies. It tells me that this is needed and this is also needed. So suppose I get now HTTPD tools also. And then I install, okay, let me clear the screen. I install rpm-ivh and httpd/tools. I install it in the same command. Then it again says APR. So I need to have all the packages available locally, whereas I can just use the yum command, like yum install httpd, or before that I can search also, yum search httpd. So it gives all these packages with the keyword HTTPD in use. Now I can install yum. I can install it using yum. Let me clear the screen. Yum install HTTPD. What it does is it not only first it finds the repositories configured on the server, and it resolves all the dependencies. So it tells that HTTPD needs this software and this software. So first it installs. You can have a watch this carefully. If you watch this carefully, you will see that first these packages are installed before HTTPD is installed. So I'm going to say yes, and you can see first download the package. It downloads the package from my repository, and this package is downloaded, and then this package is downloaded, and then but when you see that when it installs this package first, and then install its package first, and then it installs this package. So I think that answers Divyanshu's question between the yum install command and the RPM install command. So RPM is the basic thing, and yum is actually kind of a wrapper around. Yum is a wrapper around RPM. Now we looked at all these. We had a look at the source code. Now, just to give you a refresher of what I have been talking so far, we talked about the source code. Okay. Now, when we talked about the source code for Git, source code for Nano, and source code is available publicly in place of all the open source software, and this was made available but the software Nano was made available in a RPM file for it to be installed on a server. Now, the next part of this training, I would ask Abhinaya to take, because she works in my team and is an expert in building packages. So she will show some demonstration of how this package is created, how this file is created, how these kinds of files are created, and what are the things that you have to take care. Before I give to Abhinaya, I also want to emphasize that creating packages from a system administrator point of view is going to be an important component in the DevOps scenario, in the DevOps world, especially as an administrator. If you're going to have a lot of inbuilt tools, then it makes sense to have those tools packaged and delivered to the system rather than just copying it and running it. So I hope that you find the rest of the training useful. So over to you, Abhinaya.
Hello all. Actually, we'll see what is packaging and all, how to create a package. Hope everyone can see my screen, right? Okay. Okay, as Naveed said about the source code, right? First we can see what is source code. So source code would be the tar file, and I have downloaded from internet from here. So Nano is an editor, as all aware. Naveed already said about that. So once you download the source code, we have to extract the source code by using tar-faximile extraction, and we have to specify the file which we want to extract. And then once you extract, you can get the directory of the source code. So just go inside the directory. So here you can see the files and scripts which is needed to build the component of Nano. So you can see here. So we need to know how to install this Nano, and we want to know what is Nano. So the tool can get from these files, install and readme file. So install from install file we can know the installation steps, and readme file we can get about the Nano. So let me show you what is inside the install. So if you see inside the install, see the installation step is here. So the installation is, we have to run the /configure and make install. So this is the installation step, as well as we can see how to install the Nano on different OS from this file. So normally every component source code install file will be there, where we can get all the installation step of the specific component. So so first we have to run /configure to install this Nano. Let me check, is there any Nano on my system? Which Nano? No, there is no Nano. Here I am using Red Hat 6 machine. Okay. Then what is our first step is /configure is our first step. So we have to run the /configure inside the source directory. See, this is the source directory, and this is the first step to get the nano. So let me run. Yes, I'm facing some issue here is that C compiler is missing. So this is the dependency. So as you see here, see this slide is build requires means to RPM needs certain package to build properly. So nano needs the C compiler to build properly. So first we have to install the C compiler. So for that, let me search, is there any C compiler? C compiler is a GCC obviously. So there is lot of GCC available. So let me install GCC and GCC-C++. Yes, it's installing. Yes. So again, let me run this /configure. First of all, this /configure should executed successfully without any issue to create a make file. So make file is the second step to run. First, let me check whether it is running or not. Yes, again another dependency issue that this nano is needed cursors. Clearly the error is displayed that no ncursors library was found. So we have to install this nano. We have to install this ncursors component. So let me install that. Yes. Now ncursors is installed. Then again we have to run /configure. We are trying to fix all the dependency issues of nano.
Actually, and what we are trying to do here is to we are trying to compile the nano, we are trying to manually install nano on this particular Linux machine. When I say manually install, I mean install from the source code. So we are installing from the source code. So before we can install from the source code, we need to compile it. We need to convert it into a binary. We need to convert it into a machine language before it can be installed. So configure and make are the steps of building the software. You are going to build the software so that you can prepare the binary of that software. So you should not get confused between what we are installing now or what Abhinaya is installing now, like the ncursors, the GCC, GCC, C++. They are the softwares needed to build nano. They are the build tools, the compiler softwares that are needed to compile nano, compile the source code.
Yes, Naveed. Okay. Yeah. Okay. Now the first step is completed successfully, and we have done the .configure. This is our first step, and there is no issue. And then second, if you see here, the make file is got created because of this /configure. Then we have to run the second step, which is make. Yes. Now our component is ready to install, means nano is ready to install. For that we have to run make install. Yes, perfect. Now if you see, before when I run which nano, I couldn't find any nano. But if I run now, see, the component is installed locally on user local bin. If I see the nano version, I could see the 2.9.7. This is how the component can install locally. Manually, we can install locally our components. Okay, and then there is lot of options we can use with this configure. You see /configure with --l. You can see there is lot of options to install the component. So for here, I'm going to use this option. Other than user local, I can install where I want. I can install any path. So before that, let me delete user local bin nano. Okay. So if I give which nano, there is no nanos here. Let me remove this directly. So here what we are going to see is how to install the same nano component other than user local. So for this /configure, there is an option use prefix. Here we have to mention the path where we need to install the nano. So here I'm going to give the path of nano and 2.9.7. Here I want to install this nano. So I gave the path and just install. Yes, first step is successful, and then make. Yes, and then make install. So if you go out nano, here the directory 2.9.7, I could see all the binaries here, right? The path which I gave with /configure. So this is how the component can be installed locally wherever we want. So now I'm going to show how to build this nano as a RPM. As Naveed said, we can packaging. Red Hat is for Red Hat machine, we have to package it as a .rpm, right? So I'm going to show how to package it. So before that, let me remove that nano from this app. Okay. Okay. First, to build the package, first we got some idea how to build the package and how to manual installation has to do and everything. So before build the package, we need to set up the hierarchy directory. Hierarchy directory means we have to create a RPM build directory. So inside this RPM build, we have to make 6 directories called build, which is used for scratch some space to build the component, and build root is a temporary directory, and the RPMS is the output directory where we can, once the build success, we can get the RPM file inside the RPM folder. So let me show you how to do that. So first, before that, we have to create build root, RPMS, SRPMS, sources. Okay, this is the directory which we need to create. And then sources is the directory where our source file should be placed. So what is our source file? Which is here, nano. We are going to build nano. So nano is our source file which is here. I'm going to copy this to that source directory. Okay. Let me clear the screen. So this is the source directory where the source file should come. So
what also you need to understand is that this is not something that you will have to do on all machines. This is only on the machine where you will be preparing the RPM file. So what what Abhinaya is now showing is preparing the RPM file for Nano. So this is just the build machine where the build will be done, where the compilation will be done, and the compiled software will be converted to the package. So don't get into an impression that this has to be done on all servers where the package has to be installed. Once the RPM is made available, or once the RPM file is ready, it can be copied to any repository from where the individual servers can install it using the yum command.
Yes. Okay. I have my source file on this path, so I'm going to copy from that to this sources directory. So now I got the source file inside the sources directory, means star file, and then we have to create the spec. So already I have created a spec here, which is where the spec is available any Vim editor which is inbuilt. So if you give vim nano.spec or some other a.spec, so we will get the template of the spec file. By using this, we can edit and create the spec file. Okay. So here already I have created nano spec file. So let me explain this. Okay. So this is the spec file of nano. So here I'll define the name is the tag which is used to define the name of the software. Here our software name is nano. So I gave nano here, and then we have to specify the version. Here it is 2.9.7. So we have to change it to 2.9.7. Our version of the software, and release would be first, obviously, and then license of the software we have to mention here in the group of the software, and the URL. URL means if you see yum info some other component like Python or something, you can see the detail of the information of the component which is coming from our spec file. So if you see the URL is the URL where we can get details about the particular component, and then license is the license of the software. That's all coming from the spec which we are creating. So URL, so I provide some URL where we can get the detail about nano. And then source code is the tag where that directs the RPM to get the source file. So this is the source code of the nano. So I have provided the nano source code here, link here where I downloaded. So I downloaded nano from here. So I'm going to copy this link and paste here. Okay. And then build requires, yes. As when we are doing manual installation, we got some error there, dependency error, right? So there we install GCC and ncurses devel. So that is for building the component. So we have to mention here. So what is that? Ncurses devel and GCC/C++, which we installed as a dependency. So that build requires a tag to specify the build dependency of building the component. So I have mentioned here, and then description. Description would be some more explanation about the software. So I provide description here, and then prep. Prep is the tag when you execute the full script. The prep is the first section to compile the RPM. So means to create the RPM means prep will, what will do is prep will extract our source code from the source directory, and then it will put it to build, which means first section of our build process. So prep is the section to extract our component, and then build. Build is the section to mention the build steps, how to install the RPM. As we know, we already done the manual installation that build /configure make and make install is our build steps. So those build steps should come under this section, percentage build. So I already mentioned /configure. Okay. So I already show there is lot of option with configure. So I provide the enable all means it will enable all the function of this nano. So I mentioned this option here. Okay. And then second step is make. I mentioned here make. And then install step. Install step would be final step make install, right? That should be come under this tag. So why I'm here build root is, so as I told earlier, build root is a space for temporary space to create RPM. So no need of the build root to be placed in all time. So I removed the build root as by normal command. Use normal Linux command rm-rf and then build root. And then make install, and there also as like /configure, make install and make also so many options which can be make install --help. So I mentioned this is my destination directory where my components should install. So make install, our destination directory is RPM build root. Okay. Okay, perfect. And then here files. Files is the section. What are the files? As Naveed said, there is binaries, libraries. Once we install the RPM, we can get the binaries and libraries. So those binaries and libraries parts are mentioned this file section. So I mentioned here. Okay, let's. Okay. And one more thing is that if you see these all tags are called macros. So these macros are coming from RPM components. So we can see the macros by this command, show RC. RPM -show RC, this will display all the macros. So if you want to know about particular macro, let me show you. If you want to know about what is this macro means about what is this bin-dir. So that can be see by this command rpm-evaluate this macro. Okay, you see here, see the bin-dir is point out the user bin path. So the same like if you give like libdir, it will point out the user lib directory. So once you run the build command, what this tech will do is, it will check the source code by using prep section, and it will run the source. It will run the source code by by build section, and it will install. Where it will get installed on this path. Okay, perfect. So how now? Now our sources and specs are ready. Then this is the command. RPM build is the command to build the RPM. So this is also provided by one package. So one software. Okay. You see RPM-QSC. Okay, leave it. Okay. Okay. To build the RPM, there is a command RPM build -define. We are going to define the directory. So top dir, where our source directory means where our sources and specs are placed, and I place here var spwork and RPM build. So we are going to define the directory. And then there is so many options with RPM build. So here I'm going to use -build -va, which means build all the steps of specs. Okay. So build, where is my specs? Spec is where is my spec? It's under specs and nano.spec is my spec file name. So I mentioned here. Let me this. Okay. Here I mentioned the version name wrongly, so I have to change it. 2.9.7, right? Let me run again. So if you note here, when we done manual installation, we have to do /configure and make install. But here all the steps we have specified inside the spec file. So no need to run again and again. So this is how the spec file should do. Here what is actually there is no man directory inside the nano. That's why I facing this issue, file not found. So for that we have to remove the man directory from this file section. Okay. Then run again. Yes, it's got success. It's built without any issue. If you see here, see, the build is the directory where the source code got extracted, and this is our directory where our source code got extracted. And build root is a temporary directory which is deleted because I mentioned here after the installation my build root should delete it. So build root got deleted. Under build root nothing is here. Nothing is there. And then if you see RPMS, this is the architecture of our nano components. If you see RPMS folder, you will get the RPM file. See that RPM file which we can install by using yum or RPM command, or we can use both. And then sources, as we know earlier, sources is the directory where source code should be placed, and specs, we created the spec file, and source RPM. So SRPMS is the directory where source RPM gets placed. What is source RPM? We can say that source RPM is the compressed file which is contains sources and specs. Let me show you. If you extract rpm-ivh and then source rpm name, you in your root home directory, you will get another rpm build folder which contains the sources and specs of the particular component, which we can say this is for future purpose. If anyone want to know what is inside the source RPM, for that we have to extract the source RPM. So we can see our sources and specs file here. Okay, so now we got our RPMs here under RPMs folder. Okay, now we need to install this RPM. This is for build server only for building purpose. For install, we can do another fresh machine. Okay, so for this, I have to copy this RPM from RPMs folder to another machine. I have on another server to do installation. Okay. So this is my another server. I copy my all the RPM from here to here. Here no nano. I think yes, no nano here. So now we can install this RPM by using yum install. I'm going to install this nano. So there is 2 RPM here. I'm going to give start yum install nano. Just give S. Yes, it's installing. Yes, it's completed. And then if you give which nano, it will come under user bin. As you see here, already if you see RPM-evaluation with bin DAR, so this is how. So we mentioned this bin DAR inside our spec file, means where our nano binary should come. So my nano binary should come under this user bin. So it's success. See, my nano is coming under user bin nano. Right? This is how the package build should do. Then if you want to remove it, yum remove.
Just a minute, Abhinaya. Before you remove that software, I don't know if you remember the demonstration that I did. When I did the demonstration, I was actually installing it from a repository called RHEL6 or RHEL6 update. So if you see the install server where Abhinaya has installed it, you can see that the repository is showing @nano, which means it's coming from the local. So it has actually used the RPM files to install this software. So the right procedure would have been, after the RPM file is created, you will copy, or one will copy to a repository which is configured on the servers, and from that repository it can be installed on n number of machines. Also, you would notice here that I don't know if you recollect, maybe it's very difficult to recollect, but the nano that I was installing was actually 2.0.9, which is the default available in RHEL6. So can you do a yum list nano? No, yum list nano. Minus show to. No, yum list nano minus show to.
Minus?
Show duplicate. Show duplicate. So you can see here that there are different versions of nano coming from different repositories. So the third column here is the repository. So the available packages, it's showing Nano, which is version 2.0.9-7, which is coming from a repository called NSN. Whereas the Nano that Abhinaya just built on the build server and installed it locally, it is 2.9.7. So what ideally happens and what practically in a practical situation is that the package that Abhinaya built in the build server, after it has undergone proper testing and proper change management, it is placed in the repository. It is copied to the repository and such that it's made available for the users. So all the user will have to do, or the system administrators will have to do, either using configuration management tool or to manually, is to just update the package on the server, update the software so that the latest version of Nano is available on the software, on the server. So just wanted to add that to clear if there were any confusion around that. Yeah, please continue.
Yeah. Oh, this is how we have to build the RPM. So then there is another tag is called requires. So which is we are not using here, but let me clear what is different between build requires and requires. Build requires is the tag where we can mention the component which is required to build the RPM. So as while install manually Nano on this build server, we face some issues that the C compiler is not found, and another issue is N-curses is not found. So that is for building this Nano. So those components should be mentioned under this build requires. And this is requires means if you want to work this binary, means if you give which, here we gave which Nano. If you want to work this Nano, these Nanos depend on some other component to work properly. So those components can be mentioned under requires. So here, as of now, here we don't need any requires.
Just to show the difference for build requires, build requires is only needed on the build server and not on the server that needs the software has to work. So you can show here that there is no N-curses devel and no GCC on the install server.
Yeah, I'll show. Yeah. So this is where we build the component, right? Here you can see N-curses here, and again GCC also will be here, right? But if you see the install server where we install the RPM, if you see here, I hope N-curses will not be here. Yes, but the N-curses devel which we install, but that is not here. So this is the difference. So to build a component, that particular library or binary, the component is needed, but to install the component, that is not needed. So this is the difference between build requires. Okay. So what does require means? Let me install some other component. Yum install some like yum install Python or some other component. It's already installed. We install some other component. Automake. Okay. Okay, let me install Automake here. See here. So to install the Automake, AutoConf is getting installed automatically because this is the dependency for Automake. So which is mentioned inside the spec. That's why you can. Oh, sorry. Okay. When I install Automake, the AutoConf is getting installed automatically, which is the dependency. This can be mention inside our spec file, like automake spec file. Okay. So this is the difference between build requires and requires. So to work with that particular component, which is needed some other certain packages, those packages can be mentioned under requires. And as we know, prep is the section where we have to give the source code extraction steps. I already explained. So this is the prep section. We are providing setup, extraction, extract. We are providing a step to extract our source code. And then build section will contain the build steps of the component. So here our nano is contain configure is the first step and make is the second step. And then install is the tag where we have to mention the final step, make the installation. So here make install is the final step. And then clean, which we are not using here, like other than like RMS and RF I'm using here. For the instead of this we can use clean tag as well as we have to define here. And then pre and post installations. Pre and post pre means to execute some script, or if we want to install some components, we can mention under the pre tag. And then post is the tag where we can install, where we can add the script script which is need to run after the installation. This is pre and post installation. So which can, I'll show you the spec file where the pre and post installation is mentioned. Okay. Okay. You see this spec, I mean, like, okay. Okay, if you see this spec, see, the post installation means which is run after installing the package. Okay. So this we can mention what here they are mentioning to remove the info DER, means to create the info DER, we can mention whatever we want. Means after the post installation, whatever we can do, we can mention under this section. And then before uninstallation, before remove the component, what are the things need to be done can be mentioned under this tag. This is how pre and post installation should be there inside our spec file. Yes, I hope that's all from my end. Is there any queries or can be posted under chat window? I can clear.
Maybe can you just add the automake as a reserve for Nano, rebuild the RPM, and
Okay.
and then show and remove the Nano from the install server and see how the dependencies work.
Oh, okay.
Work.
Okay. 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 As Navi said, let me show you. Here we mentioned only build requires. Now I'm going to add one more tag called requires. Means to work with Nano, this particular component need to be installed. So here I'm going to mention automake. Okay, as requires means automake need to install before the Nano. This is what the meaning of this particular tag means. Automake can be added here. Then save it, and then I'm going to rebuild it. The same command we can use rpm build Yes, it's got build. And then again, I'm going to copy this RPM from here to my another installation server. Before that, I'm going to remove, because already I installed Nano here, right? So I'm going to remove Nano and as well as automate here. What is my expectation is, here if I install Nano, it should automatically install Automake, which is act as a dependency, right? So I'm going to install Nano. See here, I didn't give any other component other than Nano, but it's installing Automake as a dependency, which is mentioned under our spec file requires tag. So this is how the requires is act. Yes, we give which Nano is coming from user bin, we give which automake is from user bin automake. This is the difference between the requires and automake. See, and also see one more thing. While install Nano, it is installing only the automake, not install ncurses devel or DCC or DCC C++. It's installing only automake. Means to work with the Nano, automake is needed. To build the Nano, ncurses DCC and DCC C++ is needed. This is the difference between build requires and requires. I hope everything clear now.
Yeah, one of the questions that was asked in the chat was that how will we know which are the requires and which are the build requires? So from a build requires point of view, or even in a requires point of view, some of the basic tools are needed, like you would need RPM, you would need, there is a package called RPM build. So it contains some RPM build tools. And then you would need the compiler tools like GCC, GCC devel, ncurses devel is most commonly used. So other than these generic libraries or generic packages, the specific requirements are available in the source code. If it's a good open source project, the developers would have added the added what are the requirements, what are the prerequisites for building and for installing the package. Otherwise, it would be a trial and error kind of method where we have to just compile it and then see if you're getting any errors. Or then during the test, once the package is ready at the testing stage, maybe a different component that is needed for the proper functioning. Sometimes, there wouldn't be even any error while installing. Only, certain features may not work. So at that time, you will have to contact the developers, or you will have to troubleshoot and find out what is the component or what is the additional software that is missing that will fix the issue. So this is the first time that we are doing this training, so we didn't know that how much time it would take, and we didn't know what kind of audience would be participating in this training. But I hope we have been able to clarify all the questions. So that is why initially we thought it might take 2 hours, but it looks like we are almost like 90 minutes into the session, and we are about to conclude. So if there are any more questions, then we can handle it. There is plenty of time. Otherwise, we can stop the recording and close the call. Okay, it looks like there are no more questions. Thank you everyone for